Luigi throws an apple at a wall that's 15 meters away horizontally. If he releases it from a height of 1.93 meters above the floor at an angle of 48 degrees with a speed of 17 meters per second. Part A. How high above the floor will the apple hit the wall? Part B. Was the apple going up or down when it hit the wall? Recall the equations for projectile motion. The x component of the motion is uniform motion. Vx initial is the initial speed times the cosine of theta. The displacement in the x direction, s of x, is Vx initial times the time. The y equations are the equations for free fall. Vy initial is the initial speed times the sine of theta. Vy at any time t is the initial y velocity minus the acceleration of gravity g times the time. The displacement in the y direction, s of y, is Vy initial times the time minus 1/2 times the acceleration of gravity g times the time squared. The givens, s of x, the displacement along the x-axis, is 15 meters. Y initial, as measured above the floor, is 1.93 meters. The initial speed, or magnitude, of the initial velocity vector is 17 meters per second. The acceleration along the x-axis, a sub x, is 0. The x-axis motion is uniform motion. A sub y, or the acceleration along the y-axis, is negative the acceleration of gravity, or minus 9.8 meters per second. The unknown. For part A, y final is what? The equation, s of y, or the change in position along the y-axis, is y final, which is measured above the floor, minus y initial, which is given to be 1.93 meters. This is also equal to Vy initial, the y component of the initial speed, times the time, minus 1/2 the acceleration of gravity, g, times the time squared, where Vy initial, the initial speed v sub I, times the sine of theta, the angle of the projectile. But we must also find the time. To find the time, we will use the displacement along the x-axis, s of x, which is known to be 15 meters, is Vx initial times the time. Vx initial is the initial speed times the cosine of theta. Substitute and solve for part A to find y final. The displacement, s of x, 15 meters, is Vx initial times the time for the apple to hit the wall. Vx initial is 17 meters per second times the cosine of 48 degrees, using this equation, which is 11.38 meters per second. Rearranging to solve for the time, we get 15 meters divided by 11.38 meters per second, or 1.318 seconds. Now we are ready to solve for the displacement s of y using this equation. To do so, we need Vy initial. Vy initial, using this equation, is 17 meters per second times the sine of 48 degrees, or 12.63 meters per second. Solving for s of y, we get 12.63 meters per second times the time, 1.318 seconds, minus 1/2 the acceleration of gravity, or 0.5 times 9.8 meters per second, times the time squared, or 1.318 seconds squared. We get that the displacement in the y direction from release of the apple until impact with the wall is 8.14 meters. However, what we need is y final. So we rearrange. S of y is y final minus y initial. to get Y final is 8.14 meters plus 1.93 meters, or 10.1 meters above the floor. That's how high the apple impacted the wall above the floor. The unknown for part B was the apple going up or down when it hit the wall. We know it hit the wall when it was 10.1 meters above the floor. But to know whether or not the ball was going up or down, since if velocity is positive, the position is increasing, if velocity is negative, the position is decreasing, that is the same question as when the apple hit the wall. Was its y velocity positive or negative? So we know that the apple hit the wall at 1.318 seconds. So we need to evaluate the y velocity using this equation at the time that it hit the wall. Substitute and solve for part B. Using this equation, Vy final, which is V sub y at the time that the apple hit the wall, or 1.318 seconds, is Vy initial, or 12.63 meters per second, minus g, or 9.8 meters per second, times the time, 1.318 seconds. And we get a negative 0.2868 meters per second. Since when velocity is negative, this means position is decreasing. This means that, as shown here, the ball was on its downward arc. It had already reached its highest point when it impacted the wall. And that's the end of this problem. Time for you to work some homework problems on this material. Have fun.